All right, good morning. This is the Antibiotic Bean Lab. It's a cool lab. I really like doing it because it's one of those ones that connects easily to real life. And I want to go through it so that you're successful and understand the key points. Hopefully we've done this together in class, but if something came up and you're not there or you want to review, this video is going to help you. Okay, so some background. It's very likely you have taken an antibiotic over the past year. If you haven't, someone else in your family has. Okay, key thing, antibiotics kill bacteria that are making you sick and help you feel better. However, these drugs target structures common to all bacteria and don't discriminate between the bacteria responsible for disease and the rest of the bacteria that are normal residents of a healthy biome. In other words, the bacteria that normally live in your body and produce vitamins, digest food, increase your immunity, and many other things. Bacteria are more often our friends than they are our foes. But when you take antibiotics, you kill off everything. Okay? Over time, the overuse and misuse of antibiotics can kill off the normal bacteria, the residents that keep us healthy, and allow more resistant bacteria to proliferate or grow. Clostridium difficile, usually pronounced as C. difficile, is an example of a bacterium found in the stomach in very low normals. So you always have some, but if you take antibiotics, it kills off other bacteria and C. difficile will start to grow and you'll have more of it. Provided the opportunity, it will increase in numbers until it is the dominant species in the human stomach. And I'm not 100% sure, but you end up basically you get sick because you have too much of it. Your digestion doesn't work properly. All right, another key example, and this is important because people don't get this. Antibiotics do not create resistance, but it is a classic example of survival of the fittest, provide the selective pressure for the bacteria that are already resistant to proliferate. Okay, so in simple terms, there's bacteria in your gut, all over your body, okay? Some of them are going to be more resistant than others to whatever antibiotics you end up taking. So survival of the fittest, the ones that are least affected by the bacteria are going to be the ones that are going to grow the best, and the ones that are most affected by the antibiotics are going to be the ones you kill off first. Naturally, within any bacterial population, some species will be more sensitive to antibiotics and some will be more resistant. Variation like this is genetic and it's normal. And not only within all the different little bacteria that are C. difficile, but also between the bacteria that are C. difficile and Streptococcus and, okay, I don't know any other, MRSA, all the different types of bacteria. Okay, so the goal of this activity is to demonstrate how, with the use of antibiotics, your microbial balance can be tipped sometimes in favor of the pathogen. You will observe the response of 4 hypothetical bacteria species to various antibiotic treatments over time. Record the total bacteria count and distribution of resistant and non-resistant species. Okay, don't worry, we're working with beans. We are not working with any live bacteria. Oh, which is the next statement. 4 different dried beans and peas will represent your bacteria. They will represent all the possible residents of the hypothetical biome. And there are 3 different treatments. 1, following the doctor's orders. 2, ending treatment early. And I don't know if you're like me, I don't like taking back antibiotics. I start to feel good, I stop taking them. Or you accidentally miss a day. Okay, so those are the 3 options. Following doctor's orders, stopping early, missing a dose. Page 2. All right, your initial population bacteria is as follows. We're going to have 40 beans of species 1, which is one that is most susceptible to the antibiotic treatment. 30 beans species 2. They will be killed off on day 2. They're a little more resistant, so they can handle 1 day, but on the second day they get killed off. And you guys know that when you take bacteria, you start taking it and like it feels like nothing is happening. Well, it takes a little while for it to kick in and start killing off enough bacteria so you notice. 20 beans represent species 3, which are slightly more resistant, and 10 beans represent species 4, which is the most resistant of all. As the lab progresses, the amount of each species will depend on the concentration of the antibiotics, how long you've been taking it, the duration of exposure necessary to kill them, how long it takes before the antibiotics kick in, and just pretty much the plain randomness of your immune system. All right, so everybody gets handy dandy basket. Okay. If you are doing this at home, there's actually a way to do it without the whole basket full of stuff, but it's not nearly as good. And if you are at home doing this lab, shoot me an email, and I might be able to send you a different video. Anyway, okay, so we got some beans. We got 4 different types of beans. Oh, we got some peas in there too. Okay, and we got a little bowl. We got some cups, and we got a die. All right, so number 1, label your cups 1, 2, 3, 4. They should be done for you. Not sure how I'm going to show this. There we go. Look that. Okay, there we go. Cups 1, 2, 3, 4. Now, with my beans, okay, those are yellow beans. These are actually peas. And if you get freaked out because there's some brown peas in there, well, these ones are literally from the field. So just toss out the brown ones. It doesn't make any difference to the lab. And we have pinto beans. Right, they're spotted with pinto. And we got good old-fashioned kidney beans. Now, whichever one I have most of, I'm reading my lab here, is species 1. So it looks like I have more peas than anything else. So I'm going to count out 40 peas. Okay, I think I'm going to pause the video because this is not that exciting to watch me do that. Okay, so I'm back. What I did is I counted out all the beans. So I labeled, the cups are labeled 1, 2, 3, 4. Okay, and where's my camera? There we go. There is 40 peas, 30 pinto beans, 20 kidney beans, and 10 yellow beans. That information came from came from right here. It tells me how many beans to put in each one. Sorry. This, no, not this way. Sorry. You should have a white colored sheet that says following doctor's orders. And we're going to write in the type of beans. So this was peas. Okay. And then we had pinto beans. You can write this, but make sure you're doing it on the one that says following doctor's orders. And kidney beans. And what did I say? Last one's yellow beans. And don't get stressed over which bean is which, because if you run out of beans, I have extras, or you can borrow from another group. Okay, so before treatment, here's our count. So peas 40, pinto beans 30, kidney beans 20, yellow beans 10, for a grand total of 100 beans. All right, now going back to the lab. We did that, we are done up to there. So check, next page. Oh, and there it tells you again how many counts. So these represent, my little cups with beans in them, represent the bacteria that are in your microbiome. Okay, so the number 1 species, these are the ones that are most susceptible to antibiotics, and these guys down here are the least susceptible. All right, so now the lab, we are done the prep. Now we are ready to get going. Don't throw away the bags of beans. You're going to need those. You are also going to need, you got a lid like this. A bowl will do too. All right, so it says calculate the bacteria that are killed off by the immune system, and 10% are killed off every day. take the total number of bacteria, total in the last row, multiplied by 0.1. Yeah, okay, that seems really complicated, but here we go. I'll just show you how this works. So before we start, we had 100 bacteria, 100 beans. So what we do is we put 100 here. So this number comes down to there. And we multiply by 0.1, and that gives me 10. So without any antibiotics at all, my body's going to kill off 10%. But which 10? It's not necessarily going to be 10 of the most susceptible. It could be 10 of the strongest one. I don't know, it's my immune system. So how do we figure it out? The 10, okay, so we did that part. I'm on questions part 6. 10% of the bacteria that are killed are random, and that's where you're going to roll the die. Now, where did I lose my die? Oh goodness, I just had it. Oh, here it is. Okay. So it says if you roll a 1, you remove a bean from cup 1, place a tick mark on your color sheet. Now it says color, but we're going to start with the white one. Okay. And I'm just going to put the extra beans in this plastic bowl lid for now, because this is the spot where the dead bacteria go. And let's see if we can make this so we can see what's going on. All right, so I'm going to roll my die. Okay, of course it's a 6. I'm sorry about the sound. If it's a 5 or a 6, just ignore it. Okay, so number 4. So from cup number 4, take a bean out. That means one of these bacteria died. That goes in the dead bean spot. And this is awkward. I'm going to put 1 tick under number 4, because this is telling me which bacteria are killed off. And then I'm going to roll again. All right, I got 3 this time. Okay, so I'm going to go to cup number 3. Cup number 3, take out a bean, it's dead. And I put a little ticky mark on number 3 there. Oh, 5 doesn't count. Doesn't count. Now I got a 3 again. Okay, so I grab cup number 3, take out another one, put a little tick mark. And keep doing that. Oh, 6, 3. Okay. And I keep doing that until put that there. There we go. I can see my dead beans, my dead bacteria. Keep rolling and removing. Oops, nope. 2. Move my pinto beans. Little mark there. There's another one. And I keep going until, I've been trying to say that, until I have killed off 10 bacteria. 1. So I'm at 1, 2, 3, 4, 5, 6, 7, 8. Nope. Almost. Nope. There we go. Number 2 bean. Mark. That's 9 and 10. 2, 4, 6, 8, 10 beans in there. 10 beans in here. 4, 5, 6, 7, 8. Okay, so we got 10. How do we know to stop at 10? From here. This is what it tells me. I'm gonna put a 10 there just to remind myself. All right. So now, first thing we have to do, or sorry, the next thing we have to do is how many bacteria are left. So we started with 40. One of them died. So that's going to leave me 39. I'm just going to write 40 minus 1. Okay. Okay, I had 30 minus 4. 30 minus 4 is 26. Are going to be left. And now I've got 20 minus 3. So it was 20 to start. My natural immune system killed off 3. That's going to leave me 17. And I've got 10 minus 2. And that gives me 8. So again, these numbers were coming from up there. So immune system killed off some of them. Now we have to see what the bacteria does. This part, this statement is important, and pay attention because it changes depending on which version of the lab we're doing. This says the antibiotic kills off half of bacteria number 1. Okay, so half of 39, we're going to round. All right, so 39, it's that kind of morning, divided by 2 is 19.5. So we're going to have 20 of these left because it kills off half of bacteria, but it only kills off half of bacteria number 1. These guys, it does not affect bacteria 2, 3, and 4, so they double. So 26, I'm going to go times 2 is 52. Times 2 is 34. Times 2 is 16. Now I'm going to add that up. 20 plus 52 plus 34 plus 16 is 122. Now, that to me is kind of crazy. I just took my antibiotics. They've been acting on my system for a whole day. And I now have more bacteria in me than I did to start with. Again, that's why when you first start taking bacteria, you tend to feel a little kind of crappy for the first few days until it starts to make it kill off enough so your numbers start to go down. So what I need to do now is for each of my cups, so this is cup number 1, I need to count and make sure change this so there's only 20 beans in there. For number 2, I need to have 52, 34, 16. So I need to, at all times, my cups need to have this number of beans. And to be honest, that's not going to be too exciting for you to watch. So I'm going to pause this one more time while I do that part. Okay, so while I paused it, I took out, so there's 20 beans left in here. There are 52 pinto beans in here, so I had to add some. The ones that die, I put back in the baggies. So I also took and I emptied this one out because they died there too. Okay, this one has 34 kidney beans, and there are 16 of these for a grand total of 122 bacteria beans. And then we just repeat the process. So this number is going to go down here, 122 times 0.1. That's going to give me 12.2. So I'm going to say 12 bacteria. So I need to roll 12 times or more. I need to kill off 12 bacteria. I said or more because, sometimes I'm getting 5s and 6s. All right, so bacteria number 3. I'll bring my dead one. All right. This probably is going to work better if you have partners. Because one of you can do the rolling and one of you can do the, the bean picking. And somebody keeps track. Oop, that was a 6. There's a 2. And a 4. That was 5. Oh, there's a 1. Oops, forgot to write them down. Another 1. And a 3. Where'd 3 go? Nope. 4. See, remember, this is the immune system, so it's equally likely that the ones that are really resistant to the bacteria are going to get killed off, as opposed to the ones that are really susceptible to it. That's the beauty of our natural immune system. Is I'm oddly rolling a lot of force today. Oh, I'm going to do that. Right? You guys are cool with that? I better count. So that's 5, 6, 7, 8, 9, 10. Got 2 more rolls. Ah, that was a 6. There we go. We got a 3. Where's number 3? Oh, nope. There's another 3. So 1, 2, 3, 4, 5, 6, 7, and 10. Okay. Sorry. 7 and 5 makes 12. So that's cool. So that was my natural system killing off the bacteria. Now we need to figure out what's left. So we go to the total from before. So there was 20, and I took away 2. So that's going to leave me 12. That's for bacteria number 1. I had 52, and I took away 1. So that's going to leave me 51 bacteria. I have 34, take away 4. That's going to give me 30. And I had 16, take away 5. That's going to leave me 11. So this is what's left after my natural immunity system kills off 10%. Now we need to kill off some bacteria. Okay, the antibiotic kills off bacteria. Oh, look at this, change. So on the second day, it's going to kill off half of bacteria number 1 and half of bacteria number 2. So if half of this goes, there's going to be 6 left. If half of this goes, there's going to be 26 left. Half of this goes, it's going to be 15. And if half of this goes, wait. Got a little excited there. 3 and 4 are not affected. So this is going to go up to 60, and this is going to go to 22. All right, I'm going to pause. I need to put my beans in my cups so that I have 6 left in cup number 1, 26 and 2, 60 and 22. Okay, so I count. I got too many. 1, 2, 3, 4, 5, 6. There's 6 beans. That's bacteria number 1, the one that is most susceptible. So it's been killed, basically cut in half 2 days now. Okay, bacteria number 2, it's got 26. So it started to go down because it starts being affected on day 2. Bacteria number 3, we're getting a whole lot of them because it keeps doubling. And bacteria 4, we've got a fair number, but remember, we only started with 10 of them. All right, now I need to do my math. 6 plus 26 plus 60 plus 22 is 114. So our grand total of bacteria is started to go down. So it's 100, went to 122, 114. All right, so now we're going to multiply that. This number comes here. So that means my natural system is going to kill off 11 bacteria. And we just keep repeating the process. I'll do it one more time, and then I think you guys will be fine. All right, bacteria number 3. Nope. 4. So again, those are my dead bacteria. Nope. Bacteria number 4. Oh, rolling a lot of 4s today. Nope. Oh, bacteria number 2. Number 2 again. Nope. 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 Holy. There you go. Bacteria number 4. So I'm at 1, 2, 3, 4, 5, 6. Nope. I think there's something wrong with my dice. It's an awful lot of 4s that I'm rolling. Okay, that one doesn't count. My immune system is very strong against this one. Nope. Again. Oh, where are we at? 5, 6, 7, 8, 9, 10. Oh, one more. And that was indeed another 4. Okay, that's pretty weird. 1, 2, 3, 4, 5, 6, and 5 more is 11. So I'll put a 0 there just so I know I didn't mess up. All right, now I got to read my directions. What happens today? Oh, sorry, I need to subtract. So there were 6. None of them died. There's still 6. Oh, let me write that. That in a little box. So 6 minus 0 is 6. So 6 comes from there, and the 0 comes from there. All right, so we got 26 minus 2. There's my 26, and there's my 2. You get that. 26 minus 2 is 24. I had 60 minus 1. It's going to be 59. And I got 22 minus 8. Oh, that's hard math. That's like 14. Pardon me. I'm 99% sure it's 14. 22 minus 8. Yeah, it is. Okay. Now, what are the instructions today? The antibiotic kills off half of bacteria 1. So we are down to 3. And half of this one. So we're down to 12. And half of that one. Well, that's going to be 29.5. So that's 30. And this one doubles. So 14 times 2. So how are we doing for a total here? We got 3 plus 12 plus 30 plus 28. Okay. Aha! See, starting to go down. And you just completely keep following the instructions. Now, depending on which lab you got, the instructions are going to change from this one. This is what happens if you follow doctor's orders. Hold on a sec. I'm just going to go grab the other instructions. Okay. So the following doctor's orders is the one that we're going to do together in class. So everybody understands how to do this. And we're only going to do part of it probably together. And then I'm going to finish it on my own so we have the right numbers. Then we're going to basically throw this away because this was our practice round. And you're either going to get this one, which says missed taking antibiotics on day 3, or this other one that says stopped on day 5. It runs exactly the same. So this one says stopped on day 5 because you're feeling better. So we're killing off. Everything's the same. But then when we get to day 5, you stop taking bacteria. So whatever your answers here are here, you just keep doubling. Okay. So if you stop taking them, your antibiotics is going to stop killing them, and the remaining bacteria are just going to double for you. Or if you forgot to take antibiotics on day 3, and I'm sorry, my camera's off. This is actually a green sheet. It looks very blue on my monitor. Okay. So exactly the same. Forgot to take antibiotics in this day. Everything doubles because you forgot to take your drugs. And then it resets, and suddenly you got antibiotic kills off half of bacteria number 1, and it doesn't affect anything. So you're restarting, not with the original numbers from up there, but whatever these were. So it's always going to be this fourth line that tells you exactly what to do. So you are going to keep rolling and doing your thing until your page is all filled out. So you've got all the way through to day 10. Okay. And I'm going to finish this up later. Okay. So back to the lab. We talked about page 3. Okay. It goes through and explains in detail how to do that. You keep doing it. Okay. Then when we're done, there'll be a chart on the whiteboard to the side, and you're going to need to copy this down. I'm going to provide the numbers for this, and then the different groups will provide the numbers for there. And then you need to do the analysis and questions. And it says, for example, what is a microbiome? That's in the page, like the first 2 pages in all that instructions. You can also Google it, but make sure what you're answering applies to this. Hint, hint, reread the pages. Okay, explain this pathogen. What are bacteria? Okay, why do bacteria kill both good and bad ones? It's there. I know the answer's there. Okay, and I know the answer is also here. So then what you're going to do is you are going to make an Excel spreadsheet, or you can do it by hand. Okay, Excel is going to be a lot faster. Okay, if you've never used Excel, now is a great time to use it, and maybe I will do a second video to go with this to explain how to do an Excel spreadsheet. Anyway, you're going to end up making a nice little graph that looks like this. So the days of treatment and the bacterial count. So you've got species number 1, 2, whoopsies, 1, 2, 3, and 4. As I'm looking at this, this is kind of yucky because I didn't print in color. So I'm going to take and go species 1, and I know what it does, and it does that. Species 2. Yeah, because it started to get affected on day 2. I think if you're clever, you can figure out how to make different colored X's. I didn't the day I was making the lab up. Okay, so you're gonna have to do this. And then there is some more questions here, and make sure you're following and answering based on the group data information. So when it says explain using data from the simulation, how can infection of C. difficile can be caused by overuse and misuse of antibiotics? So you remember from the beginning that C. difficile is the one that's the most difficult to treat. It's the most resistant to antibiotics. So you want to look at what happens with number 4 and explain how this goes. Okay, so species 4. So if you misuse antibiotics, what happens? So take a look at when you stop early or when you skip a day, what happens to number 4 as opposed to what happens when you follow the doctor's orders. Okay, so how do the number and distribution of bacteria differ when the prescribed regime follow, doctor's orders and when it is stopped prematurely? So what you want to say is for species number 1, this is what happens. For species number 2, this is what happens. Okay, so when you follow the doctor's treatment, species number 1 does this. It goes down and it keeps getting cut in half and it disappears, say, by day 5. If you stop prematurely, then what happens? I don't know because I don't have the data in front of me, but I'm thinking probably what happens is there's going to be some left at the end. Okay, and what are the effects of skipping a day of treatment? And then at the very end, in a well-written paragraph, tell me what this has made you think about antibiotic use. Because I know growing up, every once in a while somebody would get sick and they're, your auntie would be phoning, do you have any antibiotics I can use? I don't want to go to the doctor. I've even seen it on Facebook within the last 6 months. I feel crappy. Anybody got antibiotics I can use? And it's like, that's just such a bad idea. in my personal opinion. And now you can see what happens. Okay, so please follow the lab. It's going to be awesome. Thanks. Bye-bye.